चलिए welcome everyone. This is 𝗙𝗢𝗟𝗟𝗢𝗪 Basic Electronics. In this lecture, we shall discuss about the current flowing mechanism inside the transistor. In the previous lecture related to the transistor, we discussed about the various geometrical and the doping parameter of the transistor. Means कि आपने ट्रांजिस्टर के किस पार्ट में कितनी डोपिंग करनी है ये हमने डिस्कस किया था और इस क्लास में हम समझेंगे कि ऐसा हम क्यों करते हैं यानी कि ट्रांजिस्टर को बनाने के लिए कुछ स्पेसिफिक हमने कुछ ज्योमेट्रिकल एंड some doping aspects को discuss किया था and we discussed the major application of the transistors and there are two major applications. Number one is as an amplifier and number two as a electronic switch. So this you will study in the digital electronics subject. In 𝗙𝗢𝗟𝗟𝗢𝗪 basic in next semester and here in this particular course we are interested in the transistor as an amplifier. So how we can use transistor as an amplifier and we discussed the definition of the amplifier and I hope and I hope we discussed the application of the definition of the amplifier in great detail. With the generalized system, we discussed the application, the definition of the amplifier. And again, I'm telling you, for the AC aspect, the amplification means if I am providing, let us suppose this is my amplifier system. So what do we mean by amplifier? I have already discussed with the generalized approach, taking this system having a gain k and then we take three conditions. When k is greater than 1, then the system, if this system is having a gain k, then if this k is greater than 1, then or gain or the transfer function whatever, it means if any signal is coming to this signal, it is modifying it with the factor k. So if any signal is coming, if any voltage signal V is coming and it is we are getting output k times V. So if this k is greater than 1, then this particular circuit or network is called the amplifier. Definitely you can understand. अगर ये k एक से बड़ा होगा, it means ये 2 है, 1.5 है, 1.5 भी है, तो definitely क्या हो रहा है, जो output मिल रही है वो input की 1.5 गुनी है, तो वो amplified है. यानी mathematically we are giving these definitions. This is amplifier, and if this k is less than 1, then this circuit is called attenuator. And attenuators are very easy to design. We can design the attenuators just by using some resistors. By having a particular combination of resistor, you can design attenuators. Resistor, inductor, and capacitors you can use in order to design attenuators. And for the amplifiers require some specific kind of devices which we are studying here, like transistor. Okay. And when k equal to 1, it was buffer. So this buffer you will study in the digital circuits when we will discuss the digital in 𝗙𝗢𝗟𝗟𝗢𝗪. And what you can understand geometrically, if we need to understand the amplification process geometrically, then we can understand if we are applying some sinusoidal wave here like this, and we are getting the output like this. So if the input is exact replica of the output, but amplitude is magnified, but amplitude is only amplitude is magnified. For an amplifier, we want the amplification of the amplitude only, because we know that for a sinusoidal wave there are 3 parameters. For a sinusoidal wave there are 3 parameters. What are the 3 parameters? Amplitude, phase, and frequency. We do not want any amplification or any change in phase and frequency. Okay, we just want exact replica of input but magnified in terms of output. मतलब in output जो हो इसके जैसी होनी चाहिए but वो बिल्कुल magnified होनी चाहिए, थोड़ी सी amplified होनी चाहिए, और that's why the name is amplifier. तो ये जो है एम्पलीट्यूड, फेज और फ्रीक्वेंसी में कोई चेंज नहीं आना चाहिए. बट इन स्पाइट ऑफ दैट देयर आर डिस्टॉर्शन इन द एम्पलीफायर्स, वो हम बाद में डिस्कस करेंगे. देयर आर फेज डिफरेंस, फेज डिस्टॉर्शन, फ्रीक्वेंसी डिस्टॉर्शन एंड इवन द एम्पलीट्यूड डिस्टॉर्शन. यानी कि जब इनपुट और आउटपुट में इस तरीके का रिलेशनशिप है तो हम कहते हैं कि when k is greater than 1 then this device is amplifier. So this we have already discussed in the previous lecture, and now I have elaborated with some geometrical figures, and we discussed about the we discussed about the significance of the transistor. At the last point of previous lecture we discussed about the significance of the transistor, how we are using the transistor in our day-to-day modern computers, in modern controllers, and a lot of electronics revolves around this transistor. So basically we need not to we need not to talk about all these things again and again. So in your daily life you are using a lot of electronics. All you need to recognize where the transistor is, and I will help you with this with this course. Okay. Now we discussed the geometrical aspect of the transistor. So transistor is basically a three layer and two junction device. So there are two junction. Now we are very much familiar with the junction, PN junction. We are familiar with the PN junction, and we know all the physics behind the PN junction. So again we will use all the physics. So three layer and two junction device, and this was the two-dimensional diagram. This is the two-dimensional diagram, and here, so and now you can understand this is a three layer and two junction device. So there could be two possibilities only. What are the two possibilities? We require two junction and three layers. We require two junction and three layers. So this is the two junctions. So for by junctions we mean in electronics there should be two different kind of semiconductors, p type or n type. So basically if this is p, so in order to have a junction this must be n, and this must be p. So if this is n, so this must be p and this must be n. So there are two kinds of transistor, because we have this is a three layer two junction device, and so there could be two kinds of transistor, PNP and NPN. And again we discussed for general purposes these both transistors works equally well. But as we know, and which we discussed in the semiconductor physics, the mobility of the electron is higher than the mobility of hole. That's why we prefer this one. Okay. So, and we will discuss the current flowing mechanism with the help of NPN, and the current flowing mechanism for the PNP is quite similar. When we are saying the difference between PNP and NPN, the only thing is this: here the majority charge carrier will be the holes, and here the majority charge carriers will be the electrons. So this is how the device works, and these were the basics that we discussed in the previous class, and we discussed the nomenclature. And this region is called the emitter region, this region is called the base region, this is called the collector region. And we discussed the some geometrical aspects. What were those the geometrical aspects? And that the doping, if we talk about doping, then this doping is highest in the emitter and moderate in the collector, and the least doping, or you can say the light doping, is done in the base. And if we talk about the geometrical aspect like width, then the highest width is of collector, moderate emitter, and the least for the base. So this was all about the introduction of the transistor, and we have already discussed this introduction in the previous lecture. I have recapitulated all the things so that the continuity is not broken. Okay, so now we will discuss the current flowing mechanism, how current flows inside the transistor, and how and why these things are like this, and three layer two junction, and then we will discuss the symbol, etc. So what is the symbol in the electrical engineering of the transistor, and how you can differentiate between NP and NPNP transistor with the help of symbol. This we will discuss. So now the next topic is the how the current flows inside the transistors. So next topic is this. वैभव,
यस सर।
इसको यहाँ पे काट दो, इतना ये सब पुराना रिकैपिचुलेट हो गया ना, अब इसको काट दो, दो हिस्सों में कर लेंगे।